Much of our understanding of the universe comes from looking at the stars and trying to grasp the true nature of the cosmos from the movement of light. But that only does so much. Recently, there have been massive efforts to actually land on planetary bodies such as asteroids and even retrieve samples for scientists to study here on Earth. So far, there have been several attempts, but only a few missions have been successful thus far. In today's video, we take a look at some of these missions to land on asteroids in our effort to understand the universe. In the last 2 decades, there have been multiple missions launched by individual countries to land probes on asteroids and receive samples that can be studied here on Earth. One of such prominent missions is the osiris-rex planetary mission kickstarted by NASA. The osiris-rex, which is an acronym for Origins, Spectral Interpretation, Resource Identification, Security Regolith Explorer, was launched as a part of NASA's New Frontier program in 2016 to collect samples from an asteroid called 101955 Bennu. Bennu is a small but ancient asteroid currently floating some 200 million miles away from Earth. Scientists believe Bennu was formed over 4 billion years ago, at a time when our solar system was still in its early stages. As such, it holds vital properties from that time that can be studied to give us a glimpse into what the early solar system was like. Developed in collaboration with scientists from the University of Arizona, NASA launched osiris-rex from Cape Canaveral in September of 2016, and after a 4-year journey, it finally reached the asteroid. The spacecraft sent back the first ever close-up pictures of Bennu's shape and its surface features. It proceeded to map out the entire surface of the asteroid, giving scientists a more detailed view and aiding them to pick the best sample collection site. This proved rather challenging, as the surface of Bennu was incredibly more rocky and filled with larger boulders than scientists had previously anticipated. It took the team several months of evaluation before finally deciding on a sample collection site called Nightingale. Nightingale was chosen out of 4 other sites, as it posed the lowest risk to the spacecraft's safety, as well as having the largest concentration of fine granulated materials for the spacecraft to sample. The site also appeared to have freshly exposed craters, giving access to the samples that were below the surface and just as old as the asteroid itself. But although Nightingale posed the lowest risk, it also had the smallest area for sample collection, which meant there was a much smaller margin of error for osiris-rex. The spacecraft had to be incredibly accurate in order to land safely on the asteroid's surface without causing significant damage to its instruments. osiris-rex had to undergo several reconnaissance flights and practice landings in order to perfect its touch-and-go sample collection attempt. Beginning in January 2019, osiris-rex carried out several flight rehearsals on the asteroid's surface until it was finally ready for its final descent. The spacecraft slowly began its 5-hour descent to the surface of the asteroid, carefully maneuvering over large boulders the size of 2-story buildings before finally making contact with the surface. Real-time data from the spacecraft indicated that the surface of the asteroid was not as compact as scientists previously thought, but was filled with loosely packed rock particles that gave way upon contact with osiris-rex. Following pre-programmed instructions, osiris-rex proceeded to fire a burst of nitrogen gas which stirred dust and pebbles on the asteroid's surface. This allowed the spacecraft's collection tray to scope substantial amounts of rock and dust particles. Shortly after, osiris-rex fired its thrusters and began its ascent away from the surface of Bennu. A look back at the collection site showed that osiris-rex had dislodged way more particles than anticipated, creating a much wider impact crater than expected. Also, due to the low gravity of the asteroid, much of the dislodged particles remained floating above ground, taking hours before finally landing back down on the surface. Images from the spacecraft collection tray showed that osiris-rex had acquired way more materials than had previously been planned. The goal was to acquire at least 60 grams of asteroid material, but the spacecraft had succeeded in collecting almost a kilogram of asteroid particles. Osiris-rex proceeded to close its sample return capsule, marking the end of the most difficult part of the entire mission. On command from Mission Control here on Earth, osiris-rex performed one last flyby of Bennu, mapping the state of the asteroid after an interaction with a foreign object. In May 2020, osiris-rex fired its main thrusters at full speed, setting the spacecraft on a path for Earth at speeds of over 600 miles per hour. The spacecraft began its 2.5-year cruise back to Earth and is expected to reach orbit in September of 2023. Upon reaching Earth's orbit, osiris-rex will separate from the sample return capsule, which will proceed into Earth's atmosphere while the rest of the probe remains in orbit. The capsule will make a predetermined landing, parachuting over Utah Test and Training Range in the Utah desert, where it will be retrieved and studied by scientists. This will mark the end of osiris-rex's primary mission and make history as the first U.S. spacecraft to successfully land and retrieve samples from an asteroid. Upon completing its first mission, osiris-rex will receive a new mission and new goals to study the asteroid Apophis. Apophis is a slightly smaller asteroid compared to Bennu, with a mean diameter of 370 meters, and is projected to come within 20,000 miles of Earth's orbit sometime in 2029. With the spacecraft renamed to OSIRIS-APEX, the mission will be to orbit the asteroid following its flyby of Earth, giving an unprecedented look into an S-type asteroid. The spacecraft will study Apophis to understand the impact of Earth's gravitational pull on the asteroid's orientation. It also will attempt to land and dislodge rock and dust particles for further analysis. The osiris-rex mission has been a complete success for the most part and has made U.S. history in more ways than one. But it wasn't the first spacecraft to land and retrieve samples from the surface of an asteroid. That title goes to the Japanese Hayabusa spacecraft. Hayabusa 1 was the first spacecraft in history to successfully land, retrieve samples, and take off from the surface of an asteroid. The Hayabusa mission was to retrieve samples from the asteroid designated 25143 Itokawa, returning the collected samples to Earth for analysis. The mission launched in May of 2003 from the Kagoshima Launch Center in Japan and returned in 2010 after successfully completing its mission. The spacecraft was also able to perform detailed studies of the asteroid's topography, shape, and density, as well as its polarimetric and photometric properties. But while Hayabusa 1 was a widely successful historic mission, it wasn't without its challenges and near failures. The spacecraft experienced a temporary loss of power due to a massive solar flare shortly after launch in 2003, causing its rendezvous with Itokawa to be pushed back several months. Hayabusa also lost the use of one of its reaction wheels, but that was nothing compared to the challenges it faced when it finally reached the asteroid. Hayabusa lost its small lander, Minerva, after deployment to the asteroid's surface. And it's believed the lander floated off into space after a mishap occurred during deployment. Upon landing on the asteroid's surface, Mission Control in Japan lost communication with the spacecraft for 3 months, before connection was re-established later in 2006. On its return flight to Earth, Hayabusa 1 lost all its chemical fuel, making the rest of the journey back home on a ballistic trajectory. But despite these challenges, Hayabusa 1 proved resilient, and all efforts paid off when the sample capsule landed in Woomera, Australia in 2010, giving scientists a first look at samples from an active asteroid. Hayabusa 2, on the other hand, had a much less challenging mission progression and is similar in more ways than one to OSIRIS-REx in terms of mission success. Hayabusa 2 launched in 2014 on a mission to explore and retrieve samples from the asteroid 162173 Ryugu. Learning from the challenges of its predecessor, Hayabusa 2 was equipped with 2 rovers and a small lander, all of which were deployed upon reaching the asteroid in 2018. The spacecraft then proceeded to retrieve its samples and made its way back to Earth. Hayabusa 2 delivered its samples to Earth in December 2020, launching the sample capsule into the planet's atmosphere, which then made a parachute landing in the Australian outback. Much like Osiris, Hayabusa 2 is now on an extended mission to study and retrieve samples from the asteroid 1998 KY26. These successful missions have given scientists an unprecedented look into the composition and origins of asteroids, helping us further understand the complexities of this vast universe.